So section C is all about types of data. So we need to be able to describe, okay? Um, so a categorical variable describes a quality or characteristic. So that's the big thing I want you to pick up here. And then there's a whole bunch of other stuff you can, so these are just examples of categorical variables. And a quantitative is a numerical value. And there are two types of quantitative. There's a discrete quantitative, which is an exact number, and you can get that by counting. Typically, when you're counting, there's 30 desks in my room. That's a discrete one because it's exact. And I listed this twice, so sorry. So like the number of apricots on a tree, the number of players in the game of tennis. Then the second thing, the second type of quantitative is a continuous variable. And continuous is usually about measurement. So height, weight, times taken to run a race, the distance hit in baseball. So it's like in between, like if we talked about how tall everybody is in the school, you wouldn't list everybody's exact height. You'd say, oh, there's this many people between 5 foot and 5'3", and 5'3" and 5'6", something like that. So continuous is always like in between a range of values. All right, so for example, this is just classifying each type. Is it categorical? Is it a number? And is it discrete number or continuous? So this is the number of heads when 3 coins are tossed. Because that's an exact value, that's a discrete variable. The brand of toothpaste used by the students in a class. Brand of toothpaste, that's categorical. It's not numerical, so it's going to be categorical. Okay. Since height is a measurement, that's going to be a continuous one. And that's really all letter C is. Letter D is going to be a little bit more in depth. And it's all in organizing discrete data. All right, so the first thing, I don't know how you want to do this. If you notice on the next page of notes, I actually put this table there. So we use a tally by using tally strokes. That represents 5. So you could have 1, 2, 3, 4, 5 as values, and then you kind of go through and mark. So the tally marks are different, and then you add them all up to count for the frequency. The frequency just summarizes the number of tally marks. And then the relative frequency is the frequency divided by the total. So here when you add everything up, I'm going to take 8 divided by 30 to get my relative frequency. 9 divided by 30 to get my relative frequency, and so forth. So a tally is just a way, I mean, you could go through and count 1, 2, 3, 4, 5, 6, 7, 8 ones. But the tally way, it's kind of like nice to go, there's 1, 1, 1, 3, 1, 1, and mark them off as you go, because this is something you've got to be super careful. You miss one tally mark and your frequency is off, your total's off, it's just a mess. So you've got to be super careful that your tally is correct. All right, so a way to display your discrete data is by using a column graph. So the possible data values go up along the, the actual values go along the bottom. Notice how the X is marked as the values. Then the frequency, how often they occur, go up and down. So if you look back to that last, actually in your note sheet, it's just up above. Since there are 8 ones, and what's really important with discrete data, there's space in between each one. So be very careful. See, there's gaps between to indicate that the data is discrete. And the mode is the most frequently occurring value. So it's going to have the highest column. So just get everything you need out of this one. Okay, so I've got the picture here. But I want you to write how we describe these discrete shapes. Okay, so if the mode is in the middle and it's symmetric, somewhat symmetric about the mode, we talk about symmetric as a way to describe the data. We'll get into, I don't know if it's the next chapter or next year, the other way to describe this, and you may have talked about this in Algebra 2 as a normal curve if it's symmetrical. Negatively skewed, that's when your tail, where the high part is on the right and the tail goes to the negative side, that's where it's negatively skewed. So your mode is on the right and it's skewed left or negatively skewed. Positively skewed is when your mode is on the left and your tail goes to the positive side, or right skewed, I've also heard that said. And an outlier is just a data point that doesn't fit. It's either much too large or much too small, and they're separated from the body of the group. So notice in this picture, all of my data scores are over here. My outlier's way over here. And there's actually a formula to determine this, and that's actually if we were to calculate a box and whiskers or a box plot. That's how you can figure out outliers. We'll get to that later. Okay, so really there's just one example, and it's just making that whole great big tally the chart, and then a column graph. Okay, so we're going to make our chart. So notice what are all the different data values. Our smallest data value, and these are years, this is their year levels at school, is 6, 7, 8, 9, 10, 11. Then we're going to make our tallies. All right, just for the sake of time and effort, I mean, what we normally do is 8 has 1, 7 has 1, 6 has 1, 1, 2, 3, 1, 9, 2 7s. So then I'm going to cross because that's 5, 11, 8, 10, 2 8s, 9, 10, 2 7s, 1, 2, 3, 4 8s, 1, 2, 3, 4, a 7, 1, 2, 3, 4 sixes, a 9, a 6, and a 9. All right. So typically then what I will do, so this is 30. So let's count up our frequency. I have 6 sixes. I have 9 sevens, 8 eights, 4 nines, 2 tens, and 1 11. So then I want to add up. There's 15, 23, 27. I need to make darn sure my total matches the total from the beginning. That's a really good way to see if you missed one. The bad thing is you don't know where you missed one if you're off, but this at least should give you somewhat more confidence about that. Okay, then we're going to figure out our relative frequency. Okay, so we take the frequency 6 divided by our total, and that's 0.2. Then we take our 9 over 30, that's 0.3. These are both exact. 8 out of 30 is our first approximated one. 4 out of 30. 2. And notice, oops, this should be a 0. 0.067. Notice I'm always going 3 decimals. And then 1 out of 30 is approximately 0.033. All right, so this is our letter A. Letter B is our column graph. 6, 7, 8, 9. I'm going to kind of be squished. You make yours a little bit, I had a little more room on my note paper than on my board here. So the highest frequency is 9. So I'm going to go up 2, 4, 6, 8, 10. And I'm going to label my axes so I know exactly what I'm going up by. This is my frequency, and this is my years. It's also good to label your axes like that. All right, so 6 goes to 6. And since these are discrete values, I need space in between my 6 and 7. 7 is 9. 8 is 8. It should be equal widths, but mine's kind of squished here. 9 is 4. 10 is 2. And 1 for 11. Okay, so we now have all of our values that we have all of our information organized. So now we're going to answer our questions based on the information that we just graphed. We just organized everything, so now it's just really about answering questions from our organized data. Okay, so letter C just says, what is the modal year? Mode is which one is the most often. Remember, that's your highest. So we can either use our frequency or our highest column. So that's year 7. Describe the shape of, now notice here's our mode. It's further to the left and it's skewed more right. So we would say it's positively skewed. Because our highest point's more left and then it goes to the right. What percent were in year 8 or below? In year 8 or below. So we're just going to add up. 8 plus 9 plus 6 divided by our total of 30. This is approximate. Now we have to pay attention to this. What percent? So when you add this up and divide by 30, we get 0.767. You need to convert that into a percent. This is your decimal value, 0.767. They're asking specifically about percent, so you need to change your decimal into a percent. And then what was above year 9? Now, notice this was year 8 or below. This is strictly above 9, so that does not include 9. So we're going to take 2 and 1 is 3. Divided by 30, that's 1/10. Or 10%.